But before reviewing those rules, let's just review about the ways that derivative can be written. The first way that derivative can be written is what? Pretty sure you know. It's something with a comma as a superscript, right? This means you are taking the derivative of this something here. That's the first way, or that's one way to write derivative. The second way to show or write a derivative, it's d over dx. It doesn't always have to be dx. It can be d data, dr. It depends on what the derivative is in respect to. So, but since in this class you see dx, they use dx like most of the time. So let's just use dx, and it was just the derivative of something. This is the second way to show or write a derivative. The third way that derivative can be written is similar to this, which is just d something. You just basically put that something on top of this line here and dx. So those are the three ways that derivative can be written. So if you see those, you see things like this, it means you're taking the derivative. Now since we finished reviewing how to show derivative or how to write a derivative, let's start reviewing all the rules of derivative. The first rule, or you know what? Let's talk about what that something mean, because all I've been saying is just something. You're taking the derivative of something, right? But what is this something? Well, something can be a few things here. Something can be constant. That something can be a constant, which is like a constant number, which is like 100, 101, 1/2. It can also be negative, as -1 over -1 over 11. That's constant. That something also can be a variable. Which is like what? X, right? Y as anything, like, and this something can also be an expression. Which is like 2x plus 1, that's one expression. Or it can be x to the third plus 2x squared minus 1, those are expressions. Or this something can also be a function, like a function y that expressed in x, which is like 2x plus 1, that's a function here. Or a function like, or you know what, use another letter maybe. Or a function like s can be a function s then also expressed, that may be expressed by what? Y? Yeah, in terms of y. So those are functions. And as you know, when you're taking the derivative of a function, like you're taking the derivative of a function y, you write as y prime, right? And then you see here, the derivative of this is just gonna be 2. So this is the derivative of this function. Okay, so And in this class, in the calculus that we're learning, we mostly take in derivative of a function. That's what we do. We do a lot of derivative functions. So now let's talk about all the rules of taking derivatives. The first rule, as you know, it's the derivative of a constant, right? A constant, which can be any number, like 1, 2, well, you know that, negative 1/3. And the derivative of a constant, any constant, is 0. So that's one rule. And the next rule for derivative, the derivative of a variable, something, is 1. The third rule, the derivative of something to a power. This is called a power rule for derivatives. It's this power times the something to the power, to the original power minus 1. So, which is like if you're taking a derivative, for example, if you're taking a derivative of x to the 8, the derivative of this will just be ax to the 7, right? So the next rule, let's do this. The derivative of e to a power, to e to something. This power is something. We don't know. It can be x, 2x, 3x. That's why I call it something, because we don't know what it is. But the derivative of e to the something is just always e to the something. Like, doesn't change. It's e to the something. So next one, the derivative of a to something, it's a little bit different with e to the something. You still write down a to the something. It's still a to the something, but there's more. You have to time the ln of a. Yep, that is the derivative of a to the something. So next, let's do the derivative of ln something. What is that? Pretty sure you remember, which is just 1 over that something, right? It's 1 over that something. And next, the derivative of log 8 to the something. 8 to the something. Remember, this is the argument. Yeah. Okay. Oh well, why did it? Okay, my bad. Should not be a equal sign here, because I'm taking the derivative of ln to log a of something. Okay, so what is that equal to? Pretty sure you're faster than me. You already remember. It's just 1 over that something, right? Similar to the derivative of log 2 to something, right? And just 1 over something, but you have to times 1 over the ln a. Yep. And which some people read it in this way. They combine them. They would just say 1 over u to the ln, or u ln, no, u to the ln, u ln. So that's the rule. And beside that, we also have derivative of two functions, right? Adding together. We have function f adding function g, kind of like that, and which we just kind of look like distribution, which is just like the derivative of f plus the derivative of g. Another one, derivative of a constant times a function, which you just take out the constant and multiply that with the derivative of the function. And after that, you have the derivative of a product, right? Product, remember the product rule? Which is just like g and times the f derivative plus f times the derivative of g. Okay, that's the product rule. And there also comes a quotient rule, which is this. F over g. Here you just have, it's similar to the product rule, but instead of a plus sign, you have a minus sign here. And fg. And you also have the whole thing over g to the square. So that's the quotient rule. And next we're going to talk about all the derivative rules for all the trig functions and inverse trig functions, but that will be the next video. So goodbye. I sound like